Hi, Nick Collier here, and this is my shop. Come join me. We'll have some fun.
Nick Collier here again, just getting over that flu that's been going around, and it is one nasty flu too, man. I'm pretty much flat on my back for about 10 days, and now I'm just kind of up and wandering around. I got a little more energy, and I'm back. So, if you've been following along, and also if my inventor guys have okayed it, I have been showing this video of this hinge that I'm making for them. And we made that one, and they loved it, and but they went, well, it's missing one component. And the component is that this arm, or this arm of the leg of the hinge, this arm of the leg of the hinge needs to be able to lock in any position. And the little screw jack that I got going here, it locks, but it's not super strong. So we had to kind of step back 5 yards and, you know, take a punt and do it again. So now we've made it in aluminum, much stronger material, does not give like Delrin does, and we're about halfway through that process there. But he said, I don't really want the sideways lockdown. I want to have a bar right in the center that I can flip over and it loosens, and then I can flip it back and it tightens. And I'm like, whew, okay, here we go. Let's just do some experimenting. I swear I have gone at this about 5 times. 5 different approaches, each spending a couple of 2 or 3 hours on each approach, and each approach has failed on me. So we're now at the final approach. Well, I hope the final approach. And I'm going to bring you in closer. Let's look at the problem, and let's look and see how we can answer it. So here's what we've got is this center arm. And I came up with this design pretty much out the gate. And left-hand thread, right-hand thread, kind of a turnbuckle sort of approach. And, you know, I threaded it, and I was like very sure of myself, no problem, let's just do it. And then out here on the ends, we'll have a little hex bolt and an indent in the metal itself where the hex bolt kind of indexes into the metal. So the bolt doesn't turn, just the shaft or just the rod, which swings up and back down. Now, all of that is good and well, and by the way, here's a little bit larger version of that, although I decided to reverse the approach and put the receiver part, or the female, on the shaft, or on the arm itself, and put the males on the ends of each of the pivots. So, yes, we approached that, and okay, and I thought, well, you know, just do a coarse threaded screw, and we'll be set. The problem is that I can only do a half turn, and I need to be able to travel more than the, I don't know, 64th of an inch that I'm traveling with this thread. So we've tried, I tried several different approaches to get this right, and haven't really come up with anything until last night. I decided, okay, well, let's give this a try. So we just kind of did and I don't know if you can see it, we did a 8 threads per inch rotation, and I just grabbed a cutting tip, you know, a thread cutting tip, and did that just to see what it would look like, and gosh, it looked like it was a possibility. So Well, this didn't happen last night. Actually, this happened 3 or 4 days ago. And then I said, okay, well, this could be the answer. So now we have to go in to the female side and make that thread. And then, of course, that's where I ran aground, because the hole for the thread is actually even smaller than the shaft. So by the time you get a cutting tip down into that hole, with good clearance and everything like that, you haven't got any metal left, and the tip just sits there and vibrates at it as it tries to cut the metal. So, I'm scratching my head trying to figure out what's going on. So I just, I don't know, yesterday afternoon, or maybe it was yesterday morning, anyhow, boom, it all of a sudden came to me, wham. So here's what I came up with. So I came out here yesterday afternoon, and I just cut a thread, the thread that I want. And it's got a little bit of an edge on the inside, so that when it screws in, it has just a bit of a grab. Anyhow, so cut it and decided that I'm going to take this and make it into a tap, and then tap the female, or the receiver part of that, and get that tapped in, and actually have to make 2 of them because we have a left-hand thread and a right-hand thread, and then attach the 2 together and attach them to the bar itself. So that's where we're at. I did this as an experiment. We're going to come back in. This is the left-hand thread. You can kind of see. And then we've got to come back and we've got to cut a right-hand thread one. Then we need to come in and cut the flutes for the tap. And then once we get the flutes cut, we need to come in and heat treat it. So there's the job. And once again, I have no idea whether this is even going to work or not. I do know that in a half turn, this travels a good 1/8 of an inch, which is pretty much all we need, is that 1/8 of an inch, and maybe even 3/16. So stick with me, we're going to have a little fun. Okay, so we've cut our major diameter. You know what, I want to measure this and make sure that we're at least somewhat close to, we're in good shape. Well, I want to measure, make sure we didn't have a taper going there. So that's pretty good. Now what we want to do is we're going to kick it into gear and slow the speed down a bit. And set our 0. Set our other 0. That's something. So we're going to cut our first thread. We're going to cut the left-hand thread shaft over again, because the other one was just kind of a test, and it worked just fine. One thing I wanted to make sure. Yep, everything is good. So we're going to make our cut, see how we're doing. Well, that looks pretty good, but I think what we want to do is just go in just a bit deeper. Make sure we've got a good seat. And while we're sitting here without changing anything, we're going to hook up the taper attachment and run a fast taper on the end of this. But first we have to figure out how much taper. The way we're going to do that is come up with a die that's already here, and it looks like it just tapers for the first 1/4 inch or so, but this is a pretty hefty cut, so I think I'm going to taper back a 1/2 inch. All we need is, oh, I don't know, a 1/2 inch of material. So we've got this huge long tap, and we're going to end up tapping something that's about that long. So we've got plenty of room to taper in on that, and I think that's gonna be where we want to go. So let's see what this taper is gonna do. No, not enough. And it looks like it's pretty much at its full extent here. There you go. Boy, that just really worked, huh? Oh no, we've got plenty of room to taper. Okay, so let's try that. So that's tapers to about there. I think we should go just a little further. There we go. That's gonna give us pretty much what we want. Let's lock it. Yeah, it might be a bit much. So let's back it up just a bit. Okay, the taper is going to end about right there, so I think we're in pretty good shape there. So we'll tighten that, we'll tighten our plates. And let's see, we can turn off the No, it's not enough. It only goes to about there. So let's bring it back and give ourselves a little bit more. Oh, no, a little less. Give that a try. Alright, well, we got to taper to there. That ought to give us a decent start. And this is our drill. This is going to be our hole size, 190 thousandths. And we are sitting at 185 right there. So that's just about right. Okay. I think it's going to work. Alright, so now what we're going to do is come in and cut the right hand thread. And we've got everything set here. Let's undo the taper attachment so we don't accidentally run it. Good start. We've got our other shaft in. Now we're going to cut the right hand thread, so we're going to go from this direction over to the chuck. So I think we should get started. Let's see what that looks like. That's it. Right there. Take a couple of spring passes. And we've got it. So now let's set up our taper. And we're ready to go there. All right, I think we did it. Now we're going to take it over to the mill and cut our flutes. Okay, so we've got our super spacer set up. We've got our tail sock set up. We are straight and in line, hopefully. And then I've got my bit in here and centered. And then I brought it this way because we're cutting left-hand threads. I brought it this way by about 10 thousandths. And so now what we're going to do is cut 4 flutes on this piece. So that'd be every 90 degrees. And I think we're about ready to get rolling here. Alright, well, we've got ourselves a slight cutting edge there. I think we need to travel in a little bit further. But for the moment, that looks good. So we're going to take it around 90 degrees and do the same thing on all of them, and then index down afterwards. So there's 90. Bring it around. Yeah, that did it. Now we got an edge. Okay, good, good. So, take it over back to 0. Okay, that's it. We got ourselves an edge. Let's take it out and see what it looks like. Okay, I'd say it looks pretty damn good, and the edge is pretty sharp. I think we're gonna get a good cutting edge out of that. So let's cut the other one, and then we go into the excuse me, we go into the heat treating process. And this one is a right hand thread, so we've got to go center and 10 degrees the other direction. So that was 10 and 25. So there's 10, 20, 35. Yep, perfect clearance. Tighten up our tailstock just a little bit. Nice. And we will be back soon. Okay, so we've got our teeth cut, and now what we've done is flipped it around, and we need to cut a square so that we have something to grab onto when we get ready to run this in as a tap. So just a quick square, shouldn't be a problem. All right, done deal. So now I think we'll just take it over to the saw and lop off that end. I already did the other one. So, okay, we'll be back. All right, well, I've mixed a boric acid and in this case acetone. Usually I use alcohol, but I didn't have any alcohol. So boric acid and acetone, and kind of got a little slurry going, and dip these in that material so that they would so that the oxygen couldn't get to them while they're coming up to temperature. So we're going to put them in the oven or in the kiln. We're going to close the kiln up, and we're going to let these babies soak. sure that we're not. Yeah, looks good. Take it up to, swing it over here. We're going to take it up to 1570 degrees, which is where they want, or where 4140 wants to heat treat. And then we'll dip it in canola oil. So I'm going to kick it up just a notch or two. And we'll be back in about a half an hour to check on this. I'm guessing it's going to be up to about 500 degrees in a half an hour. And we'll go from there. Okay, so we're up to 1550. We got the door open. We're going to get our little piece out here. One of them, and drop it in the canola oil. Let it cool a bit down to about 100 degrees. That looks like it could work. Do it again. And that's the deal right there. And there's probably just a little bit warm. All right, we'll come back once everything's cooled down and, see what we can do about tapping some holes. Okay, so we're getting ready to thread this. We've drilled it out a couple of sizes over. We did the first one, and this is the second one. So, and it's a fight. So what I've done is I've brought my tailstock in and tighten that up. And as I turn in, I'm going to push with the chuck against the I can't remember what it's called. The tap wrench. There we go. So just bring it in, turn it. Bring it in, turn it. Basically, I'm just butting this up against that tap wrench every 1/8 of a turn or so, just to get that first thread started. Once it's started, it'll go. I mean, it's a fight, but it will go. Now it's starting to get pretty tight. Yeah, get a little more goat juice on there. Alright, now it's starting to bind, so I'm going to back it up a half a turn, break the chips, bring it back in. I mean, you have to understand, we're running 8 threads per inch at a 1/4 inch. So this thing is traveling fast. Okay, I think we got to start. Yep. Alright, we can pull everything back. Alright, I think we're just about punched through. There it is. Not too bad for homemade, huh? Or shop made. We'll get that to go in. And it's traveling pretty fast. Good deal. Okay, so now we got to come back in and trim this, but since we're all set up with 8 threads per inch and everything set up, I'm going to do the shafts now, and we'll come back. Alright, so we need to cut a hex at the end of this, and we put it in our hex collet holder, and we're just going to trim off all of the edges. Alright, well, okay, I think we got it. We got 6 sides there, and that's about a 1/4 inch, so that's all we need. Okay, well, we've got our hex on one end, and we need to put a center in the other end so we can get this thing out in the open air and turn it down. Alright, there's our bolt. Now all we got to do is take it over the little lathe and put our threads into it, and I think we've got it together. Well, let's surface this edge or that face there.